And welcome to the Daily Space Weather. If the imagery looks a little bit differently today, it's because it's coming at you from the GOES-R as opposed to the SDO, the instrument we usually use for our videos. Thanks for tuning into the Smash News Network, least busted name in news, as we bring you the most detailed imagery of the sun and comprehensive space weather you'll find in the known universe. So, it's been kind of quiet on the past 24 hours here, and you can see a shadowy moon there, partially eclipsing El Sol. And if you're wondering what the GOES-R is, it's one of the geosynchronous geostationary satellites, the GOES operational environmental satellites. If you want to read more about it, just look up the GOES-R. Tons of information there on their website about what that is. And in the northern limb, we've got this massive filament, which one of our viewers named the Gene Simmons. You can see a little bit of a partial collapse happening yesterday. The leading part of this did largely collapse back down toward the chromosphere. The rest of it is still intact. It is a large filament indeed. Here's the northwestern limb. Let's go around the horn here in a clockwise fashion. There's your southwestern limb. Well-defined coronal hole here, and there's a forecast for geomagnetic storm conditions coming in about 2 days. Here is our southeastern limb, and at least one new sunspot has recently formed right there. You can see that bright area there. This is ionized iron plus helium, by the way, 304 angstroms ionized helium, 195 angstroms ionized iron. There's a close-up of those quite massive sunspot groups. They haven't changed a lot in the past 24 hours. And there is just the eastern limb. All right, let's blast through our volcano report here and see what is erupting. Abico is erupting. It's producing a 8,000-foot plume of volcanic ash as it explodes. Flight level 080 over Paramushir Island. Suino Sejima, 6,000-foot ash plume. Luatolo, 6,000-foot ash plume as it intermittently erupts. Small white to gray plumes. Semeru, exploding, flight level 130. It's a 13,000-foot plume of volcanic ash over East Java, Indonesia. Kilauea has stopped erupting, although seismic activity and ground deformation remain restless. Popocatépetl exploding, flight level 200 over central Mexico. It's a 20,000-foot ash plume. 15,000-foot ash plume over Guatemala from San Chiquito. 16,000-foot ash plume over Guatemala from Fuego. Nevado de Ruiz exploding, flight level 220. It's a 22,000-foot ash plume over Colombia. Sangay in Ecuador exploding, flight level 200. 20,000-foot ash plume. Sabancaya unable to detect. Don't assume it's not erupting. And please, do not pole vault the caldera. Last but not least, Nyamuragira in the quote Democratic and quote Republic of Congo reported an effusive eruption there on the 13th of March. Only 9 days late in the reporting of that, although the intensified situation also continued on the next day as lava fountains appeared pulsating within the crater. Next, looking at global seismicity, there is your 90-day bar graph, and we did have one significant quake at least. It was a 6.5 near the Pakistan-Afghanistan border and also near the Indian-Asian plate boundary. That's the location of that 6.5. Not expected to have done that much damage, as it was indeed at 187.6 kilometers depth. It came in at 16:47 Universal Time yesterday afternoon. And let's check the rest of the list. We'll report quakes over a 5 magnitude as we're wont to do most days. Here is our 5.6 at Chile. That happened at 17:38, less than an hour after the 6.5 at Afghanistan. And the North Mid-Atlantic Ridge saw 2 5.0 magnitude quakes, only 3 minutes apart there. almost in the exact same location. There is some activity at California. We won't specifically cite it. South Sandwich Islands had a 5.3. That was at 2:25 this morning. Japan had a 5.6 at 7:37 this morning, Universal Time. And Iran had a 5.1 at 10:38 Universal Time this morning. Quick reminder, any earthquake can be a foreshock. Sometimes we get forewarning of earthquake activity via foreshocks. So here's some more splentacular imagery from the GOES-R. That's 284 plus 94 angstroms. Again, some magnetically complex sunspots here underperforming in the past 24 hours. In the past 48 hours, really. Here is 171 angstroms. That's another 24-hour video from the GOES-R. And let's take a look at some additional data. The 10.7 centimeter radial flux is now down to 152 solar flux units. So a little dip in the radial flux since yesterday. And our regular viewers are well aware that the radial flux is a proportional set of data to sunspot number. You can see the troughs and the crests are indeed associated. They're directly proportional to each other. The radial flux and the sunspot number there depicted. The black line and the red line, that's the one-year graph from Solon.info. Geomagnetic storm conditions forecasted here by NOAA coming on Friday. Yeah, Friday, late in the day Universal Time, expecting a KP6 there is NOAA from those coronal hole high-speed streams. So that's exciting. We are hoping to see some aurora here in Pennsylvania. We will have to take a look at what's going on just after sunset, just after it gets dark, actually. So that should be exciting. Hopefully we will see some aurora here. KP6 forecasted there late in the day for March 24th. By the way, if you enjoy the content and you prefer to see it continue to exist, remain publicly visible, and free for all of you, consider supporting the channel with some merch purchases. Yeah, we've got all kinds of merch. If you visit the link below the video, you'll find the merch in order of best selling. Of course, I'm not only Smash-O-Mash, but I'm also a client. So, of course, I am wearing the bestseller. And whatever you do, please do not pole vault the caldera. And thanks for the comment, Cookie Spacey. So that's today's featured product. It's Do Not Pole Vault the Caldera. This public service message brought to you at massive personal risk and expense from Smash staff and I. So drop some merch, perhaps. It makes great gift ideas, by the way. Some merch there. Great for gifts. Get ready for your summer outings with some Smash-O merch. Again, links below the video. Also on the homepage at smashomash.com. Thanks to everybody who's picked up merch. Do Not Pole Vault the Caldera is indeed our bestseller. And don't forget to follow us on on Twitter as well. We are also on Twitch, obviously. This video was originally streamed to Twitch. We are also on Twitter, so make sure you follow us over there. If you don't have an account, create an account. If you'd like to try the free mushroom gummies, the samples are still there while supplies last. And the link to the free mushroom gummies giveaway is right there, pinned to our profile, so check that out. You'll get focus, sleep, and stress gummies. And you can find also links to the Hemp Lucid shop at smashomash.com, our homepage, the official homepage of the Smash News Network, least busted name in news. So help us out with clicks if you are unable and or unwilling to open your cobweb-encrusted wallet, and increase the probability that these videos will continue to exist, remain publicly visible, and free for all to view. Help us out with clicks. Visit us on social media. Press the share button. Leave a comment. Tell your friends and foes about us, etc. Thanks to everybody who's been involved. Next, we'll look at Earth's magnetic moment from space. Here are the past 4 hours of magnetohydrodynamic pressure. The units of that are nanopascals. That's what's depicted by this space weather modeling framework. You should see the pressure drop off a little bit here in the past couple of hours. There we go, a little bit of a pressure decrease there. And it's all caused by the shifting vertical component of the magnetic field. Here's Earth's magnetic moment from the ground. We'll talk about that shifting component here in a moment. So Earth's magnetic moment from the ground here calming down in the past couple of hours, and it has to do with, again, changes to the vertical component of the magnetic field. So that's the past 4 hours of Earth's magnetic moment from the ground depicted in nanotesla. Here's our planetary K index, currently at 3.67. Just this side of geomagnetic unrest conditions there, KP4 would be geomagnetic unrest. And we are expecting this to drop back down to like a KP3. And the reason why is because of the measurements at Lagrange 1 of the real-time solar wind. So we do see a decrease here. Oh, check it out. The plasma temperature and speed have both decreased. But most importantly is this top frame. So this top frame right here, that red line there, that is the vertical component of the magnetic field. And when we see that solidly in the negative zone down here, especially if you have a strong field, which is the white line, that's the actual field itself. When we see a negative BZ, we see a lot of induced current from incoming solar plasma. As opposed to just bouncing off the magnetosphere, it flows into the magnetosphere. So that's what the negative BZ does. That's why it's associated with the strongest geomagnetic storm conditions. Current conditions are about 10 protons per cubic centimeter for the solar wind density, solar wind speed 515 kilometers per second. A little bit of a reduction there in the past hour. Continuing on to our GOES magnetometers, there are the GOES magnetometers. Looks a little bit like a coronal hole wind impact there. If so, it's a pretty weak one. Sometimes there are multiple streamers coming out of coronal holes. We often don't know where they're located until they arrive at Lagrangian point 1, where the real-time solar wind's measured. And let's take a look at the heliospheric current sheet next. So Earth is in a south pole current sheet. However, there is some activity here over in the east. So we may see right there, you can see a north pole current sheet popping through. That could be a result of that new sunspot in the southeast. That does pull the solar B field down, which does affect the polarity of the heliospheric current sheet. Here's our line of sight field plot. You can see Earth's sector boundary crossing there as Earth moves from a north pole to a south pole current sheet. Solar B field depicted here in blue, north solar polar fields in green and red, which is north and south respectively. Continuing on to coronal holes. There's our coronal hole line of sight plot. And it looks like we've got more coronal holes rotating in here in the east. Also, more migration happening there. You can see part of this change is a result of the north solar polar field starting to migrate down to the south. You'll actually see that happening right there, right about there. You can see that north solar polar field moving a little bit as it is in the process of leaving the north heliographic pole, a super important aspect of solar cycles. And here are coronal holes in the GOES 16 SUVI 195 angstroms wavelength. That's the past about 2.5 hours. Great view of some major coronal holes there that are very well defined and of south pole orientation. So that's south. This is south. And let's look at sunspots next. Again, we will have at least one more named sunspot group. I think there's going to be another named group back here too. I think we're going to have two named sunspot groups, one down here and one up here. Today they'll be 3262 and 3263, I suspect. It depends on if they stay intact or not, or if they grow, obviously. And here is some ground-based solar observatory. Sunspot data from El Teide, Spain. So again, these groups have largely been stable for the past 24 hours. No major changes happening there. There is still a pretty high likelihood of large flares around the southwestern limb. Although those groups there look like they have indeed shrunk a bit since yesterday. So there still is likely magnetic complexity there. Let's take a look at magnetism. This is also from El Teide, Spain. And if you see some funky looking activity up here, it's probably because of some cloud cover. You can see the entire sun is dimming. You can see the limb is getting a little bit jumpy there. An indication that there are probably some clouds or even just thick water vapor can produce an effect like that. Again, that is a ground-based observatory. Next, looking at energetic particles and flares. No spikes in the proton flux here. It is continuing to subside down to a baseline level. And flaring, again, has been underperforming, although we do have a background C-class level of output, about a C1. And we've only had sea-level intensifications here for the past 24 hours. Here are the past 24 hours, and 94 and 131 angstroms from the GOES-R. And that brings us to a little bit of astrography, orienting ourselves to the locations of things in space. This is our star chart from skyandtelescope.org. If you're up before dawn, you might see Saturn. And if you're viewing the evening sky after sunset, you might see Mercury, the Moon, and Jupiter as they chase the sun across the ecliptic. You're a little bit less likely to see Mercury. The Moon is barely a sliver at the moment, and happy new moon to all my reverse werewolves. So here's what's going on in the solar system at the moment. This is our solar system forecast. Keep in mind, this imagery is not to scale. Those things are really far apart. For example, it might look like Jupiter and Ceres touch each other as it goes through the orbit. They're not close together. Anyway, here's your 1 week solar system forecast. That's where things will be on the 29th. We will go from first to second quarter for lunar phases as the Earth continues on through its motion in a very lonely portion of the solar system. Next, moving to coronagraphs. And coronal mass ejection activity has been quite minor in the past 24 hours. Those are yesterday's images. That's 93 frames from George Mason University. Those are not earthly directed coronal mass ejections. Here are today's images, another 24 images showing up there. Also not likely to be an earthly directed coronal mass ejection. Let's take a look at stereo A's view as well while we're looking at coronagraphs. There is stereo A plus. The Soho Lasco C3 on the right. And pay attention to the time and date stamps there, because on stereo A, that's showing the 18th, the 19th. There's a bunch of missing data in the feed. And you can see Mercury over there on the right side. That is the planet Mercury on the Soho Lasco C3 coronagraph. Again, quite a low number of coronal mass ejections since yesterday. So here are some 24-hour videos. We've got the GOES-R SUVI, 195 angstroms there, along with the coronagraphs. Let's get a little bit closer. And how about one more step? And one of the advantages, actually, when the feed goes down, when we're unable to see the SDO, what's really cool about that is that it actually gives us the ability to, it requires us to go look at different data sources, right? And often, like so many things in science, we end up with answers to questions not asked. So, we recommend that you immerse yourself in the data. That's part of the reasoning for the channel, as we weren't trying to explain the solar sunspot cycles. We just got answers to questions not asked. So it's time to publish them. Anyway, there's some great imagery there for you. Some CMEs not likely to be earthly directed. Based on the available data, we do not anticipate those to be earthly directed coronal mass ejections. Is that enough caveats for you? And let's move on here to our ground-based hydrogen alpha imagery from El Teide, Spain, to show filaments. And as you can see up here, the Gene Simmons filament has indeed partially either collapsed or erupted or both, but a large part of it is still intact. And that is still a really large filament. It's probably like maybe 14 Earth diameters in length. So that's what's up. Here's the past 24 hours in the GOES R 304 angstroms wavelength. It's ionized helium, if you're wondering. The ultraviolet emissions of ionized helium in the solar corona. And here's the past couple of hours from the GOES 16. So there's a little bit of activity happening right in here. You can see some plasma looking like it's getting a little bit unstable. Besides that, things are looking fairly chill at the moment. A little bit of plasma reorientation happening over here as well. Likelihood of flares remains kind of high, as these are magnetically complex sunspot groups. And let's move to our bonus feature segment. Jackie 2 asks, what was that passing the planet there? That was the moon. The moon regularly eclipses the GOES 16, and it regularly eclipses the SDO as well. So here are our bonus features. This is satellite charging hazards from the satellite's community dashboard, and indeed we do see some significant charging hazards here moving into the central Pacific Ocean there. That's low energy electrons building up on the outside of spacecraft. Could cause some minor communications errors. If you see some glitchiness in your, for example, your GOES West imagery, that could be caused by those surface charging hazards. Next, the GOES electron flux here, climbing up off the floor. That's the past 3 days as measured by the GOES 16 and GOES 18. And let's continue on to our forecast model. There's the forecast model. They're expecting an uptick. And one thing I would say here, certainly if we're going to see a coronal hole high-speed stream impact, by Saturday, we can expect this back down on the floor, especially if it's a major coronal hole high-speed stream impact. And here is the one-year graph of the relativistic electrons. That's basically all the same data right there, folks. That's the GOES electron flux, the raw measurements. It's literally measuring the particles. This is the forecast model by NOAA, and that is the one-year chart to put that in context. That is measured at the F layer of the ionosphere, right here at the bridge between Earth and space, about 300 kilometers of altitude. Feel free to pause the video on this frame if you're not familiar with thermospheric temperatures, electromagnetic radiation penetration into atmospheric layers, and the chemical density of the thermosphere. Here is that one slice of the atmosphere, the vibrational frequency of the bridge between Earth and space, the F layer of the ionosphere. So that's what's going on, and if you're not familiar with looking at this imagery, don't worry, we'll show you the anomalygram as well. Keep in mind, folks, March is the most geomagnetically active month of the year. So it's been pretty chill here for March so far. Don't be surprised if it goes out like a lion. There is still ample time to see major geomagnetic events. And if you're not familiar with why this is, it has to do with the angle of attack of incoming solar particles versus Earth's magnetosphere. There is an effect called the Russell-McFerrin effect that kicks in as a result of that more perpendicular angle of attack, and that excites electrons in the outer Van Allen belt, which creates geomagnetism. It's part of the mechanism associated with Earth's geomagnetism. I'll say that. Anyway, here is the latest image. We're going to let that play through one more time there. And of course, most of the anomalies here are currently around the South Atlantic anomaly. No surprise to our regular viewers there. There's the latest image, 12:15 universal time, ionogram and 12:15 universal time, anomalygram. That is anomaly in megahertz from a 30-day median. Next, the total electron content forecast. We're going to show 3 different views of this. It's the free electrons between your GPS satellite and your handset, a run of about 12,500 miles. Here's the globe view. We are seeing some electrons a bit out of place there around the South Polar region. Also some around northwestern North America, a bit out of place there. And you can expect to see this get quite anomalous on Friday. When we see a coronal hole high-speed stream impact, we do expect to see some additional GPS errors here. Things are pretty normal at the moment. So here is our total electron content. This is just the anomaly from the 10-day average over North America. And indeed, there are some high electron contents there. Just pay attention to the time and date stamps, and you'll be golden. We're going to show just the U.S. as well. Here's just the U.S. And unfortunately, these are not current images. Those are images from yesterday, so we're going to skip that and invite you to check out the Hemp Lucid shop. If you haven't checked it out, you can find links below the video to the Hemp Lucid shop. And if you're just shopping on hemplucid.com, don't forget to enter the promo code SMASHOMASH to save some dough on your checkout. If you want to support the channel via a subscription, consider becoming a member of the Smash team at the Gold or Gold Annual Paid Up level. There's also a Silver level and a Bronze level. Thanks especially to the Smash team for making the operation slightly closer to being sustainable. So we would continue to create these videos if we are able to. That is the preference. The likelihood of that continues to drop as we're paid just this side of nothing to put the content on YouTube because of pathetic censorship on all pathetic big tech platforms. And I mean especially Google, Meta, and Twitter, the 3 most pathetic, 3 of the evilest companies probably in the history of mankind. Smashomash.com/Smash Team. We do provide additional content for Gold and Silver Smash Team members. We do send out email alerts, click posts. You can find links to the forum there, thanks to the viewer who recently created a new forum topic. And let's get to meteorology. And we're looking for the lowest pressure. We're pressure chasing right now. And the lowest pressure in the world is not up there by the North Pole. Although that is pretty low, 969 hectopascals. Got any lower pressure? Well, indeed we do. Antarctica. Showing some pretty low pressures there, 957. 952, I think that's close to the lowest pressure in the world. And just a quick look back at the North Pole here. There's some significant turbulence here because you've got high pressure over Greenland and Canada. Keep in mind that does push weather systems. Maybe I should do a longer explanation of what that means. We don't want the video to be too lengthy. Let's get to our regularly scheduled surface winds and jet streams. So there are the surface winds of the eastern world. Here are the jet streams. We show them daily on the channel. And if you're going to forecast global weather patterns, the jet streams would be the way to do it. Here are the jets of the western world. If you want to view it yourself on nullschool.net, it's a 250 hectopascal winds. Here are the surface winds of this side of the planet. Huge wind variations there in the North Atlantic. A little calm area here surrounded by higher winds. Here are the surface winds of the central world and, of course, the jet streams. Next, how about clouds and fog over the Americas? There is another ghost satellite. Might even be the same one. That's the Earth-facing suite of instruments. 3.9 nanometer infrared radiation shows clouds and fog. At nighttime, you can see the day-night Terminator rolling in there. Here's the Terminator. And let's take a look at our weather.gov map as we zoom in closer and closer to the United States. Or, if you prefer, AUSA, the allegedly United States of America, former nation, now banana republic. There is the key for the map. If your location is lit, click your location at weather.gov. We're not weather.gov weather ambassadors, officially, at least not yet. And since we've got a bunch of weather alerts, we've got 4 forecasts for you here. Here is the forecast for temperature anomaly. Warm temperatures coming to the east, and it's going to stay cold in the west. That is temperature anomaly in degrees Celsius for the next 72 hours, based on the GFS model timestamps there in the upper portion of the screen. Here is pressure and precipitation, and we're expecting some very strong storms here to pop up in Missouri, Illinois, and Indiana. Coming in actually 2 waves there. Going to be some severe weather, likely including things like damaging wind, hail, and possibly tornadoes. So be prepared for that. That is a very, very strong low, or at least a very strong series of storms based on a 72-hour GFS model. Here's your 72-hour GFS accumulated precipitation in inches, and check it out, expecting like 6 inches of rain there for portions of Missouri, Illinois, and Indiana, especially also parts of Kentucky. And Arkansas going to see some significant rainfalls. 72-hour GFS accumulated precipitation. And here is accumulated snow depth change in inches for the same model, the GFS 72-hour. And since it's now spring, let's take a look at the snow totals. Where are we at? So there is our snow depth map. And, geez, the snow capital of the U.S. .3, not bad. There's an area with 64 inches. Quite a bit of precipitation showing up there around California. Anyway, there's our snow map, and let's take a look at Global Cryosphere Watch to see the current state of affairs for the Northern Hemisphere. So now that it's spring, we should start to see snow totals shrinking down a little bit, I would suspect. So let's look at the snow extent first. The snow extent is kind of low for this time of year. It's just about 1 standard deviation below the mean. That's actually the plus and minus 1 standard deviation there inside the blue lines. That's a 1998 to 2011 plus or minus 1 standard deviation. Snow extent, keep in mind, it does not include mountains, has just moved back into the plus 1 standard deviation line. That's between 1982 and 2012 average. So that's officially 7 winters in a row with record snow for the Northern Hemisphere. And check out the snow water extent, the snow water equivalent rather. That is almost off the graph. And it's, well, let's just say it's well over 1 standard deviation above normal, which would be the upper blue line. So expect an epic melt season this year. Hopefully temperatures won't jump up too quickly in all those snowy spots because we're expecting massive flooding as a result of this. So expect that in your forecast. If you are downwind from a ridiculous amount of, if you're downstream from a ridiculous amount of snow, be prepared. It's going to be a crazy melt season, and keep in mind the temperature can change drastically, causing massive melts. So here's our lightning mapper, and it's been quite calm here. There was some lightning in California. Let us know if you know about any thunder snow. Here's a real-time lightning map from lightningmaps.org. I think we may have some terrestrial strikes here. Is there thunder rolling in? Some recent strikes there near the, what is it? In northern Missouri. So some thunder showers happening there. Doesn't look super extreme. And let's close this thing out with Doppler and some more satellite imagery. So there's our U.S. Doppler. There's the full 50 states of ALSA. I'm going to press refresh because it looks a little jacked. I suspect that precipitation isn't actually vanishing up there. Not exactly sure what the deal is with that. Let's focus on the lower 48. Some oddities showing up there. Not sure exactly what that's all about. Let's move on to our satellite data. There is clouds and fog. And if that doesn't give you enough information, the water vapor should clear things up. So, I mean, what you're getting in Missouri here is some rapid cloud formation and huge pressure gradients forming. So it's all caused by this dry mass of air forcing its way to the east, encountering some moisture out there, and then seeing a massive pressure gradient form. It's basically an atmospheric waterfall. Continuing on to this is the recap section to close out the video. U.S. Doppler radar, ground-based systems showing vertical motion in the air column. Space-based system, 3.9 nanometer infrared radiation satellite showing clouds and fog. And the water vapor satellite showing the water vapor, all of the water vapor. And thanks for tuning in to the Daily Space Weather. And thanks for realizing the Smash News Network least busted name in news exists. We're frankly surprised that you've found the channel. So we'll see you soon. Don't forget to check our playlists, and don't forget to visit the links here and here and here.